Okay, continue then. Huh? The coursework. Did I correct it? Those are good questions. The coursework, yes. Well, you mean the end of the semester?
Yeah.
No, that makes more sense. This Friday. This Friday, I hope. Okay.
Do we get the new book?
No, because I don't have it yet. So I'll have pages for you for the moment. Because, I made this last night at 1 a.m. So I don't have the rest of the book made yet. Yeah. Okay. No. Actually, oops. Here.
It's difficult for us to get the file and sort it there.
It's difficult for what?
To, put it in the file and...
Oh yeah, that's so hard, isn't it? Yeah. Maybe I'll print the book out at the end, if you lost any sheets. Okay, so next topic now is residuals. So, this is the last topic on this section, which means after this class, you could actually start your coursework too. So I might give it to you early, not so that you can do it now, but so you can start maybe thinking about it. Okay? What? What did she do? Huh?
So how long do you give us the coursework to be done?
2 weeks to do it. Oh, do it. What's up? Something good, is it? Oh, tell me. What? Alright. Residuals. So this is the last lesson on this section about the regression line. So let's have a look here. Okay. What's wrong? I know my pen is a bit weird. Okay, what would you say the correlation is here? What would you say is the R squared here? What type of number do you feel it would be?
0.8.
Yeah, something like maybe even better than 0.8. We'll say at least 0.75. So imagine I said to you, okay, use your line, predict what you think the value would be. I'll just call it here at A. So you'd go up to the line and you say, okay, I think the value will be this. So let's see, go across here. So we think the value will be this. Now, will it be that value? No, because there's a little bit of a error. So it could be a little bit higher and it could be a little bit lower because each of these points were not quite on the line. So if, for example, I call this point here, this one here y1, and I call this one here y1, and we put a little hat symbol on it, that distance there is the error. So I can call this error 1. Is it a big or small error? It's pretty small because this is pretty good. In fact, this error is what a residual is. That's a residual. It's the error. So the residual, or the error, is the difference between the true value minus the value you think it should be on the line. And now that's just it. It's just that difference. That's a residual. So this here, this is the actual data value. Oops. I don't like this new version. I updated over the weekend. Data value, and this one here, this is the predicted value. It's the value you think you should have on the line. It's this one here. Now you actually can simplify this formula a little bit or make it more useful. yi minus, so how could we predict what value it should be according to the line? Well, it would be a plus b xi. That's what it should be. If I use x1 here, I'm expecting to get this point on the line. So I could write it like this. Okay, so these are called residuals. Let's make this a little bit clearer by having a look at some numbered examples. Have you got this part written down? So residual is another word for error, but we use it in statistics to mean the difference between what we have and what we expect. The difference between the data and the line, which is the model. Right, so let's have a look here at an example. I'll just put in I don't know, 4 or 5 numbers. Okay, so we'll just say oh, physics, you don't want that. Come on, delete. There we go. Alright. X and Y. Okay, so let's go with 0, 1, 2, 3. Make it easy. And then this would be 1. What by 2 and not 1. 2.9, 5.1, 6.9. Okay. So you can write those numbers down if you want as an example. So this is like our first example. And let me put in the graph for you as well. Chart. Scatter, XY, next, X, Y, graph, finish, insert, trend line. Maybe I'll make the numbers a little bit bigger since it almost looks like it's perfect. I don't want it to be perfect. Shrink it down. Oh, too much. Come on, move. Oops. I'm just going to change these numbers. I'll change that to 25, 75, 25, and then 75. It's still too good. 1.5, 2.5, 5.5, 6.5. That's better because it's worse. Alright. You can't really see with the first point because the first point looks like it's on the line. But Have a look at the second point at 1. How much of a residual is that? Visually, how much is it? It looks like about 0.5, doesn't it? Plus or minus? Minus, it's less than what we thought. And then for the next residual, it looks like it's 0.5 as well, too much. So positive 0.5. And the last one, again, it's probably negative 0.5 as well. Okay? So let's see how we can calculate these residuals. So first we need to calculate the line. Now, we did this last week. So we'll... Yes, I kind of do. N SXY minus SXXY over S NSXX minus SXSX. Yeah. And then the other one then for the intercept. We'll cheat and get the program to calculate it for us. So the A is the intercept. So before I give you the answer, have a guess. What does the A, the intercept, look like it should be?
A little bit more than 1.
Yeah, a little bit more than 1. And it is. And the B? What do you think now for the B? Have a guess at the B?
Less than 1 or?
Well, less than 1 for sure. About 2. Yeah, 1.8. Okay. So what I'll do is let me just move this graph over to the side here. Make a bit more space. Okay, can you write these two down? So A is 1.3 and B is 1.8. So what I want you to do for me is just calculate the first y hat. That means the first value you think y should be. If you want to go back to the notes, this part here is like the y hat. It's the value on the line, the predicted value. So what do you think it should be? What should it be?
1.8.
Should be 1.8 because it should equal A plus X times B. So it should be 1.3, not 1.8. It's A plus BX. The X is 0, yeah. Alright, give me the next value. Tell me what the next one you think it should be. So, the value here on the line. 3.1 and so on. Okay, please add these to your table. So these are the predicted values. You got that? Yep? Okay. Now let's calculate the residuals. Okay, ready guys? So how much is the first residual? I don't think it's minus, but what's the number? It should be 0.2 with error. Okay, so you can write these down. These are the 4 residuals. Got that?
I didn't understand how you find the y hat.
The y hat, what I did was, are you happy with this being my equation of the line? So for example, if I put x equals 1, what value do I get on the line? I get y equals 3. But did I get y equals 3 for my data point? No, I got like 2.5. So anyways, to calculate the 3, all I did was put my x value into the formula for my line. So here it's a plus bx. So for example, this one would be a plus b times x. And this one here would be a plus b times x. And this is how I'm predicting what the y should be. Okay, have you got that written down? Right, now, you should be able to tell me this without calculating it, but what is the mean of the residuals here? Yeah, what is it? The mean of the residuals, the e's. Somebody said it? It's 0. You don't need to, well, if you add those 4 numbers together, what do you get? 0. Do you think this will always be the case, or not? What do you think? I think yes, always, because when you make your line, you always want some points under it and some points above it. And in fact, that line that you have here, it's always going to make the mean of the residual 0. It's always going to be a line in between the points so that the total residual is 0. So in fact, it's always 0 for this.
What if like the values were some numbers?
If they were what?
Now we have 4.
4 numbers.
What if we have 5 for?
Ah, okay. It'll still cancel. It just looks nice here because there's 4. You have 2 cancels with 2. But if there's 5, it'll still cancel. It's just you can't do it with your eyes. Here I can clearly see it's 0, but with 5 it just means you have to add them up and you will get 0. Yeah. So the mean actually is always going to be 0 here. Okay, so now I want you to get the standard deviation. Now there's only 4 numbers and the average is 0. So in fact, I think you should use the first formula I gave you. Do you remember the square root and then you have x minus x average? No, I see, going back to this guys. Use this one, because you know what the average is. What's the average? It's 0. So you just have to add the squares of the residuals. You know which one? This one. Use that, get me the standard deviation, please. You know which one to use? This one. Yeah. That's your calculator, Malik, isn't it?
Yes.
Is it really?
Yes.
Well, where's your real calculator?
Just another value.
No. Where is your calculator? Yeah, so use that one. It'll make me feel better. No, I believe you, but it'll make me feel better. Yes? Oh, did I write it AX plus B last time? Oh, it is. I wrote AX plus B. It doesn't matter. You understand what I meant. Sorry guys, I got a little confused. I think in the last class I wrote AX plus B, and today I wrote A plus BX. Yeah, you understand what I meant. I'll change it to M and C so there's no confusion. This one here is M and C. That's better. Have you got the page from that class? You do it, can we see the page? Where do I say A and B? No, the other one. The other one, yeah. You got the standard deviation? I said B is the intercept and A is the slope. Nice. For today's one I wrote them backwards. Should be AX should be. I'll have to fix that later. Okay, have you got the standard deviation? Yes? What did you get? 0.2 could be. Yeah, what did you get an answer? What do you mean no? Why not? You know how to do this one. So standard deviation, square root. Yeah. What's the first number? 0? 0.2. 0.2 minus 0 squared. And what's the next one? Okay, so go. Come on, give me the answer now. Hang on, I'm calculating it. Right, got an answer now? Come on, guys, I did this on my calculator in 5 seconds. Come on, give me an answer.
What's your answer?
No, what's your answer? What's your answer? Yes. Yes. Answer is 0.447. Okay, you got that? Yeah. Okay, so the reason we care about residuals is this. Do we have 3.5 on this graph? No, we don't. It's missing. But it's only a little bit away from 3. It's not too far away. So we think, okay, if I draw my line straight up here, I can predict what the y should be for 3.5. That's what I want you to do now. I want you to tell me what you think the y should be for 3.5. And you should use your formula here. Y equals mx plus c. So when the x is 3.5, tell me what the y equals. So we can calculate that. What did you get? Is it? 7.6, yes. 7.6 is what I got. Let me just bring that. Now,
How do you know the real one?
Say again?
The real one, the 8.
The real value? We don't. So for this one, we don't know it. What we're doing here is we're making a prediction. So this is what happens in real life. You take some data, you find a line, and then you can use this line to make a prediction about a situation you don't have. Like in economics, for example, you could say, this is the demand when the price is this is the demand when the price is this, so you can make a line. And you can use this to predict, okay, what will the demand be if the price is 3.5 euros? Do you understand? And so what we're doing here is we're making a prediction. But of course, we know it won't be exactly 7.6. It could be more, it could be less. Because when you look at the other examples, were any of them perfect? No. What was the biggest error I made? What's the biggest mistake between the points and the line? The biggest residual? 0.6. And what was the best case? 0.2. So you understand that our prediction of 7.6 is not perfect. It has a plus or minus part. You know what I mean? Like it has a, oh, we could be this much or this much wrong. So the question now is, how much of a mistake did I make? How wrong could I be? So that's where this number comes in.
But we know the R, so we know the range, like.
We know the what?
The R.
Which OR? Oh, the OR squared. Yeah, the OR, yeah. The correlation.
Yeah.
Yeah.
So we can like see that it will be like between it's minus.
That's what I mean. We want to get what is the range it could be between. So the answer would be 7.6 plus or minus. Now, how much of an error do we think we made? So this is where we use this number, the standard deviation of the residuals. When you make a prediction, you have a plus or minus twice the standard deviation of the residuals. So in this example, it'd be plus or minus 0.447. So plus or minus 0.894. This is how much of a mistake we think we could have made. 7.6. Whoa. This is how much we don't know how wrong we could be.
This is maximum or minimum.
Yeah, it's like 7.6. You're right, Malik. It's like the maximum minimum. So it's important in statistics when you make a prediction that you say how much of a mistake you think your prediction has in it. You know, the level of error that you have. So you notice that the number I use here is a little bit bigger than the worst number we had in our data. So for example, here, what was the biggest error? 0.6. So this is actually the reason why we use 2 and not 1. If you use just 1, 0.447, that's not really being honest, because if I said my error is 0.447, well, that's right for 2 of my points, but for the other 2, it's actually worse than 0.447. So whenever you use 2 of these standard deviations, you can be confident that all your errors are within 2 of these. That you'll never be more than 2 of these away from the true value. Yeah. Why 2 is actually something we'll see later, because maybe you think, well, why don't I use 3 of them and then be very sure of my prediction? Well, what would happen if you use 3 of them? It would be bigger, wouldn't it? But then that would be kind of more useless. So if I said, how tall is this student? This student is 1.5 meters tall plus or minus 10 meters. That's pretty useless, isn't it? Because that's way too big. So you don't want your error to be too big because then it's useless, but you don't want it to be too small because then you're not being fair. So this is why we use 2. And it's not a rule, it's just a guideline to use 2. Some people use 1, some people use 3. And in some situations you use 6. You use 6 when you want to be very, very careful if you're doing something with, I don't know, somebody's life depends on it. Okay, but for us we'll use 2. I'll give you the worksheet now to practice some of these, but the whole lesson is about calculating the residuals and then using the residuals to make a prediction and to place limits on your prediction, your best and worst, max and min errors. Okay. Now, when I give you the worksheet, I confused A and B. So I think last time I said AX plus B, and today I said A plus BX. You can change it on the worksheet, okay? I don't think it changes anything. Only 2 questions on it. Like I said, I made it at 1 AM, so you'll allow that small mistake between A and B. I think you should get question 1 done in the 10 minutes that are left. Can I close this? Can I close this? Yeah.